Mathematics, Common Core Connections, book number 3, problem number 1-6. That's CPM, College Preparatory Mathematics. That's a publisher. Common Core Connections 3, problem 1-6. It's a fairly simple problem because it's super early in the book, and they usually start with the easiest problems. I have some binder paper here. I have some fine tip markers by Faber-Castell. I love these pens. These are awesome. And it's optional. You don't need a calculator, but it's nice to have one, especially if you're going to use it to check your arithmetic. A lot of my students have a bunch of problems with their arithmetic, multiplication, addition, subtraction, anything like that. Alright, so the problem says Susan's apartment is shown at right. I'll draw the diagram. Assuming that all rooms are rectangular, find the areas described below. All measurements are in feet. We're supposed to find the area of our living room. We need to find the area of her entire apartment and how much larger than her apartment is her living room. And there's one more part here. Find the perimeter of the kitchen. This is a multi-part, multi-step problem. Very, very consistent with CPM's philosophies in solving problems. And I love these problems because there's so much to think about. So let's get started. First, I always like to just draw the picture. Draw what it looks like. I know there's a drawing in your book, in the textbook, online, or actual hardcover book, but it's always just nice to draw what you have. Okay, I'm going to use some colors here to color code some stuff. We have the bedroom. We have well, Susan has, I don't have these, bathroom. Susan has a living room. I'll just use a big L for living room. And kitchen. K for kitchen. There are various measurements that are given. Right. The bedroom is 10 feet on the left hand side. The living room is 18 feet on that same side, giving the total to be 28. The living room has a length of 15. Okay. And then the kitchen over here on the same side has a length of 8. So we have your width and the length or width. It doesn't matter which way you call it. Usually the length is supposed to be the longer side, but some people call that side the width as well, depending on what your shape is and what you're doing in the problem. For example, for televisions, the longer side is usually called the width instead. Sometimes. It's not all. Alright, so I'm going to show you this one particular way to solve this problem. There are lots of different ways to solve problems. That's another reason why I love CPM. CPM allows you to be open-ended about the way that the methods that you use to solve. Okay, so first up, we need to find the area of the living room. Living room, I had color-coded it as blue, so I am going to use a blue pen for the area of the living room. Okay. Alright. Well, we know that the area of a rectangle, they did say that this is a rectangular shaped room, and if you split apart a rectangular shaped room into pieces like this, the pieces are going to be rectangular as well. So the area of a rectangle is length times width. Length times width. That means the area of the living room is going to be 18 times 15. Okay, you can pull out your handy dandy calculator. You can plug it by hand. You can pause this video right now and do the arithmetic yourself, and then check with me. I found the area of the living room to be 270 feet squared. And ta-da! Indicate your answer. Always indicate your answer. Make sure you indicate what your number is answering. There's lots of different parts to this question. Okay. Alright, area of the living room done. Area of the entire apartment. Alright. So, looking at the entire thing. Well, this left-hand side has a length of 10 for the bedroom, 18 for the living room. Total is going to be 28. So 28 is going to be the length of the entire apartment. And down here is going to be 23. 15 plus 8, and I really should write it out. I gave myself some space there, so I'm gonna squeeze in this part. So where I got that 28 and 23, you do need to tell people, whoever's reading your work, where on earth did you get these numbers when it's not automatically clear from the initial problem. Okay, so 28 came from left hand side, 10 plus 18, and 23 came from 15, the bottom, 15 plus 8. Okay, now it's pretty clear as to where I got those numbers from. Alright, 28 times 3. 28 times 3 is going to be... Pause. Alright, go ahead and try to figure it out. Use a calculator, you can do it by hand. Ready? Okay, let's check. I got 644 feet squared. Did you? Alright, did I do it right? Sometimes I do my arithmetic wrong too. And I've been teaching for 5 years. And I've been doing math for much, much longer than that. So even people who are very experienced also make some silly errors. So don't worry about making mistakes. It's always good to double check. That's what you do when you double check. Okay. Alright, 2 parts down, 2 more to go. How much larger than her bedroom is her living room? Alright, so green for bedroom, blue for living room. We're going to compare these 2 rooms. Well, first of all, how big is the bedroom? We know how big the living room is. We just need to figure out how big the bedroom is. Bedroom has an area of 10, and then, oh, no markings here, but since it's rectangular, we can assume that 15, the width of the living room, is the same as the width of the bedroom. So 10 times 15. Okay. You'll notice that I use several different ways to write multiplication with this x, little x sign. I use parentheses to indicate multiplication. I can use the dot symbol to indicate multiplication. Doesn't matter. All these symbols really mean the same thing. And the more symbols you know, the more flexible that you can use them, the better you will get at math. Right, so user symbols are very important in math. Okay. 150 feet squared will be the area of the bedroom. Is this my answer? Good. No, it's not. We're trying to find the difference. How much larger is the bedroom than is the living room than the bedroom. And this is actually, I'm going to pause right here and make a note because there are these two things. This is pretty common in Math 8. Okay. The phrase, how much larger, or how much smaller, versus the phrase, how many times larger or smaller. Students, especially English learners, get this confused a lot. How much is the quantity? How many times is the product or the division problem? Okay. So this, how much larger, is the difference between the two things that you are comparing, while how many times larger is going to be a product or division. And you'll know that these, I can even say difference or sum, addition. You will use addition or subtraction to solve how much larger, and division or multiplication to solve how many times larger. Okay, we'll talk about the bottom one on a different problem, but for here, we will just find the difference. So let me get a regular black pen. I'm going, oh actually no, I'll color code everything. Let's color code. Color code is awesome. Go Avid. Okay. So we want a difference. Living room minus the bedroom. That's 270 minus 150. You'll think that this is kind of annoying to switch back and forth between pens, and it is sometimes, but it's super useful to help you understand where everything is coming from, so that the other numbers don't kind of mesh together. They don't kind of become a swamp of numbers. Right, 270 minus 150. You ready? Are you ready to check? 270 minus 150, that is 120 feet squared. Okay, and I'm gonna pause right here. I'm not indicating the answer yet because the way the question is phrased, it makes you assume that it has to be a short answer. How much larger than her bedroom is her living room? So we need to write a sentence here. Susan's living room is 120 feet squared larger than her bedroom. Be specific. Okay. Susan's living room is 200 feet larger, is where a lot of students like to stop. But larger than what? Larger than your foot? Larger than your school, your classroom, your bike? How much larger is it? You gotta be specific. To answer the question fully. Okay, alright, then we can indicate our answer right here. Ta-da! It's okay to box words, box a phrase as your answer, because it is your answer. It's you're indicating which part of this, of the things that you've written down so far, is your final answer. Okay, 3 parts down, 1 more to go. Find the perimeter of the kitchen. Kitchen is in pink. Yay, pink! Go pink. Alright, so let's scoot back up here to the original picture. Look at the kitchen. I know it has a width of 8 and a length of, good, 18. 18 is the length of the kitchen. Alright, so knowing that, the perimeter of my kitchen has 4 sides, and perimeter is the length of all the sides of the figure. That's the definition of perimeter. You can help you, I like to tell my students, that whatever will help you remember what the difference between perimeter and area is. Area is the stuff inside your shape. That is totally mathematical, yes, the stuff inside your shape. While perimeter is kind of like, if you ever watched the TV show 24, Jack Bauer always sets up a perimeter. The perimeter is to surround the shape, surround the bad guy, surround whatever is happening here. So I got 4 sides. 2 sides are length of 8, and 2 sides have a length of 18. Altogether is an addition problem. Okay. Give you a moment to figure that out. You can do it step by step, add the 8s first and then add the 18s, or you can just do it all at once. It doesn't matter. Okay, as long as you indicate where these numbers are coming from, it's pretty clear that these numbers come from the original diagram. So we don't have to do what we did here for the entire apartment. We have to indicate 10 plus 18 and 15 plus 8 as to get 28, 23 to indicate where we got those numbers from. Alright, you ready? 52 feet is the perimeter. How come it's not squared? It's not squared because perimeter is a one-dimensional length, while area has 2 dimensions. Right, a square is 2 dimensions, while just a line is 1 dimension. I dropped my cap, I had to pick that up. Haha, I love pink. Alright, so we have indicated our perimeter for the kitchen. And you know what, for the sake of being consistent, I'm going to write kitchen right here. A little bit messy, a little bit kind of all over the place, but hey, it's pretty well, it's legible, right? You can read it. All the color coding helps you. It helps whoever is reading your work. Okay. So math is messy. Math is messy. It doesn't have to be perfect. You can cross things out, you can erase, you can just do whatever you need to do in order to do the math. It's that simple. Just start wherever you're at. Alright, that is College Preparatory Mathematics, Common Core Connections 3, problem number 1-6 by Teach Me How to Math. Alright, if you have a problem, let me know, and happy travels on your math adventures. Bye!